Hi, this is Adding and Subtracting Radical Expressions by Paul, Will, and Ben. Let's look at a simple radical expression, like 4 times the square root of x to the 5th. If we really break this down, it's actually 4 times the square root of x to the 5th. We have to treat these as two separate units. The square root of x to the 5th, we can't really understand what it is because we don't know what x is. So we have to treat this as one unit, and this is one unit. A good way to remember that 4 times square root of x to the 5th are two separate units is by thinking of it the same way you think of 4x. It's not 4x, it's 4 times x. Now, one thing to know before you start adding and subtracting radicals. You have to make sure that the values inside the radicals match each other. This is x to the 5th, this is x to the 4th. These are not compatible. This cannot be determined. But what if they were compatible? So let's make x to the 4th into x to the 5th. These radicals match, so we can subtract these two radical expressions. All you have to do this is subtract 4 from 3. So it would be 1 times the square root of x to the 5th. Or we could just write that as the square root of x to the 5th. But wait, that was only subtraction. Subtraction is only half of this. Alright, shut up. Okay, so let's have 5 times the square root of y to the 3rd plus 8 square root of y to the 3rd. All you have to do to do this, that's right, you just add the two outside values and you'll get 13 times the square root of y to the 3rd. But this isn't all. Up next is Ben Shibble.
Hello, my name is Ben Shively, and today we are going to show you an example on how to add and subtract radical expressions. The example is shown below, which is the square root of 12 plus the square root of 75 minus the square root of 3. The first step that you do to figure this problem out is you need to factor out the square roots, so then the square root of 12 turns into the square root of 2 times 2 times 3. The square root of 75 turns into the square root of 3 times 5, and you don't factor out the square root of 3 because it is factored as much as it can already. The second step is adding all the pairs of numbers since they all are still square roots. So in the square root of 2 times 2 times 3, there are two 2's, so that turns into 2 square roots of 3. Then the square root of 3 times 5 has two 5's, so it turns into 5 square roots of 3. And the square root of 3 gets dropped since it has been factored already. The third step is to keep simplifying after you are done factoring. So 2 square roots of 3 plus 5 square roots of 3 equals 7 square roots of 3. And you then drop the square root of 3 again. Then the final step is to add or subtract based on the type of problem you have. In this case, we are subtracting. So 7 square roots of 3 minus the square root of 3 equals 6 square roots of 3. And that is your final answer.
Thanks, Paul and Ben. Now on to a real-world example. One of the careers that I have discovered that uses radicals through my research is in the medical field. Before determining the proper dosage that a patient might need for a drug, the doctor will have to calculate his BSA, or body surface area. This measurement will let us know how much of a certain drug that your body needs, or somebody else's body needs, for that said infection. One way to find or describe a patient's BSA is through the following formula. Body surface area equals the square root of weight times height over 3,600. Now let's suppose a doctor needs to order prescriptions for 3 different people. Matt, Ryan, and Blake. Now let's suppose Matt is 160 pounds. And he's also 180 centimeters tall. Now let's say Ryan is 180 pounds and 180 centimeters tall. Now let's say Blake is 180 pounds and 160 centimeters tall. Now if we just take all of their heights and weights and put it onto our formula right here, it may look a little something like this. There we go. So now all we have to do is simplify our numerators. So we know 160 times 180 is 28,800. Okay. Moving on. Now for Ryan, we know that 180 times 180 is 32,400. Now, for Blake, 180 times 160 is 28,800. Now all we have to do for our patients to determine their BSA is to divide. Now for Matt, 28,800 divided by 3,600 works out to be 8. Now 32,400 divided by 3,600 works out to be 9. Now for Blake, 28,800 divided by 3,600 is 8. So we can finally find their body surface area. So Matt's body surface area will end up being 2 times the square root of 2, because the square root of 4 is 2. The square root of 9 simplifies down to 3. And the square root of 8 simplifies down to square root of 4 times the square root of 2, which simplifies down to 2 times the square root of 2. Now since the doctors don't want to put in separate orders, we're going to have to add all 3 of their BSAs up to get what we need to order from the drugstore. Now we're going to take all their final BSAs and put it up into a new expression to evaluate it. So Matt's BSA plus Ryan's BSA plus Blake's BSA. So we can't really do much with that 3 right now. So just to be more comfortable, I'm going to reorder it like this. Now, we are able to add these two because the radicals do match. So this ends up to be 4 times the square root of 2. And then our 3 just falls down and we get our final answer of 4 times the square root of 2 plus 3. In conclusion, the doctors can now order in bulk as opposed to ordering in separate shipments, which allows them to save money using this measurement that we just discovered through adding and subtracting radical expressions. Now if we wanted to be exact, we could say that the square root of 2 is approximately 1.4121. And then we could times that by 4 to get 5.65685 plus 3 to get their total combined BSAs of 8.65685. This has been our real-world example for adding and subtracting radical expressions. Hope you guys learned something. Special thanks to Ben and Paul for helping me out with this project. If you guys have any questions, feel free to leave them in the comments below.